everyone. My name's Andrew. I want to talk to you today about a side project that's been very close to my heart for a while. 3 years ago, I got inspired to build a game for the browser. 3 years on, it's lived and died as a React app, and now it has new life again as an Elm app. It's called Seeds. If you've ever played Candy Crush or Two Dots, it might look a little bit familiar. So I want to start by showing you a bit of the game. So this is Seeds. The core game mechanic is that you collect seeds and resources to complete a level. When you complete all the levels in a world, you'll save the flower from that world. It's got a very kind of like bright, vibrant, minimalist feel, but it's got a somber message about saving our natural world. So I'm going to collect some rain. We'll collect some seeds. So you can play this on desktop, mobile, tablet. Collect some rain. And there we go. We've won a level. Yeah. Cool. So if you want to play the game, you can go to seedsgame.com, and then the code is open source on my GitHub. So for this talk, I want to address two key questions. Why did I make it? And what were some of the most interesting points that I found on the journey to making it? So to start with, why did I make it? Does anybody recognize this game? Yep, couple of hands. So this is Two Dots. It's a game for iOS and Android, and it's the idea of the game is that you connect dots to win the levels. Warning, it's very addictive and a lot of fun. So I started playing this about 3 years ago, and I just fell in love with it. It was so much fun, and it's got these really like bright colors, but I was really surprised by how little there is actually on the screen. It's got this very kind of minimalist design, and I just got really obsessed with it. Does anyone recognize this game? Couple more hands. Yeah, this is Monument Valley. So I was playing this at the same time. This is a masterpiece of visual design and game design. It's absolutely wonderful. You play as this princess called Ida, and she's wandering through these like Escher-like monuments that are puzzles, and she's been tasked with restoring the sacred geometry that she's stolen from these monuments. And again, a bit like Two Dots, there's this very minimalist, bright feel, and there's not much on the screen, but it's got so much depth and emotion. At this point, I was so inspired by these games. I thought, wow, I want to make one of these. Like, I have no idea how to. Like, because at the time I didn't even know how to code. So, but I had the kind of preliminary ideas for Seeds. At that time, I was like sketching things out on paper and trying a few things out in Illustrator. So it was part of my motivation to learn to code. It was just like, I want to do this. So at the time, I just started a boot camp in London called Founders and Coders. It's a 16-week program where we learn full-stack JavaScript. And near the end of the program, we did a 15-person project in React. The thought of a 15-person project now makes my head spin. But we were tasked with building like kind of like a clone of Amazon Marketplace, which we called Shamazon. So Shamazon would take payments, but it would never send you products. Whilst it was, so we were a very cohesive group of people. Like, we all got on really well. We had great pairing experience, but I was really taken by how well we were able to collaborate on this massive project. And I feel like a big part of that was actually down to React. And I got really excited about React. I just loved how simple the mental model of it was. It's like, given a state, render a view. If that state changes, the view will change. And I got really excited about that and wanted to kind of learn more and do more. So at the time, I'd also watched a talk on YouTube about somebody experimenting with making games in React. And one of the things he said was that games are just very stateful user interfaces. So I thought, what if I play around with making seeds in this? Like put a couple of things, like make the board, put a couple of things, just try it out. And I was hooked. I was like, wow, this is amazing. Like how much I could do with like not that much code and really, really low barrier to entry. I was like, I was a goner at that point. So it's kind of been my philosophy throughout the rest of this project, is to do a lot with a little. And that philosophy goes through both the visual design all the way through to the code. So spoiler alert, I stopped using JavaScript. This is probably a broken record story in these kind of conferences at the moment, but about a year in, like, there were small problems, and my gosh, just the number of them started to increase so much, and this just resulted in it just really painful to change and refactor anything. Like, I had some different ideas for the game. It's like, oh, maybe I want to try out something different. Just blank screens by the end of it. And this was my side project. I was kind of just doing it for fun at the weekends, and that just got really boring. So it just got abandoned. RIP Seeds prototype. If you want to check it out, the remnants are there. So yeah, I could talk about Seeds forever. I could bore you to death with all of the details, but I'm going to talk about some of the things that I found most interesting using Elm, kind of along the journey, like surprises, pain points, and just some nice things I found. So what did I deem as the most interesting points? So there was scaling the app, there was a point upgrading to 0.19, and then animating things. So let's start with scaling the app. So when I started the Elm version, I just started with the board, like I was sort of building out the functionality around that. But then as I wanted to add things like the intro screen, there's like the hub view, like update view, our model got very large. And I actually started to find this quite stressful reading the code. It was just this, like, these enormous files, and I just wanted a bit of clarity reading the code. So I thought, okay, I'll split things up. So I thought maybe I could split like the complex bit up into scenes. So I thought, right, I'll make a types, a state, and a view module for each. Thought that seemed sensible. And then in the main file, I added these scenes as like fields in the main model. So this led to some slightly funky, things. Like these are some of the imports that I had in main, where I had to import the types and the states with these kind of slightly weird aliases. These are some of the update the individual scene functions, and then, yeah. And it just made me think, why not this? Just why not that? And then a slightly thornier problem came when I wanted to use shared data between the scenes. So each of the scenes all need access to the size of the screen, so like the window. I ended up with this lovely branch, an update, where you're just funneling each of the values into each of the scenes. And none of this was like particularly bad, but it all just kind of felt a bit icky. I was like, something's not right, I don't like it. So around the time of 0.19, I had a look at Richard's single-page app example and the Elmlang website, and I noticed that both these approaches had modeled complex sections of the apps as pages where all of the types, init, update, subscriptions, and view lived in one module. So I thought, why don't I try scenes in this way? So goodbye, type, state, and view. I will not actually miss you. It's turned out a lot, what felt like a lot more sensible. So the imports turned into this. We had, I have like a top level scene type that will hold on to each of the individual models. And actually this ended up reducing the number of invalid states that are in the app. But what about the shared data? Well, one of the patterns that I really liked in both those examples was that they had this idea of a session. So it's kind of like the session would hold on to things like the logged in user or certain bits of data, and it was basically shared data. And so I felt context was a more fitting word for my particular application. And what was really nice about this is that each of the individual scene models could hold on to their own context. And whenever you're changing scenes, you can pull out the context from each of the scenes and kind of daisy chain it along to the next model. But at this point, like, the files were starting to get really big, and I was like, oh, I don't like this. And, like, I didn't really like the idea that I wanted to just kind of like look at the code at a glance and see which bit corresponded to what. And the solution to this was actually just adding comments. Like, that was the like, pardon the pun, it was a game changer. And, like, it just gave such a simple way of, like, carving up the different sections of that file so I could just look at it. So I was a lot happier at this point. Like, the scenes with the context really, like, made my life better. But actually, like, the comments made the biggest effect to me. And it's like what Elm format does as a default gives you, like, this really kind of, like, nice spacing around it. And it was really easy to tell at a glance which section. And I was thinking about this, the look of the code, almost like the aesthetic of the code on the screen, kind of mirrored what the game looks like as well. There's a lot of blank space. I was really surprised at, like, what a simple change, like, so kind of, like, low tech made the biggest impact for me. So yeah, I want to talk a bit about a moment that happened during the upgrade to 0.19. So the upgrade was largely uneventful. There was a couple of things that broke. There was, like, some infix notation. There were a couple of libraries that I had to drop because they used a lot of infix notation. Time was a bit different, but I'd made, like, a really, really extensive use of inline styles. But there was quite a significant change in the inline style API. So before, style would take a list of tuples. The first string is, like, the style name, and the second is the value. But after it had turned into a function that took 2 strings instead. And I thought, oh my gosh, I'm going to have to, like, rip out so much of the view layer, like, because it just was not compatible with what I had. But I realized that I had kind of absent-mindedly aliased style before as this, or aliased the tuple as this, and I'd written, like, a bunch of helper functions that would take styles. And the reality was, like, this was such a breeze to refactor. Like, I hadn't even, like, planned that, but it was basically just, like, all I had to do was re-implement the style function to my own making, and everything just worked. I was really surprised by this. The most, like, innocuous change just made the app really resistant to really flexible to change. So I went on to lock down the type using an opaque type, and this gave me a lot of extra safety and control over how this is working. So I thought from this approach, like, I want to try to do this with some of the other modules. And I'd realized that the board was one example. I'd used a dict to represent all the board tiles. This line on the top was kind of spread throughout the code base. So I started trying to move all of those functions into one module and make the API nicer. Like, it's actually, I think it's, like, a lot easier to read what's going on now rather than what was above. So my approach was to start with a type alias, and then move all of the logic for that data type into its own module. And then using import as was actually a really useful thing for me. It kind of made the code a lot more readable for me, and then locking down using opaque type. So I'm going to talk about one of my favorite topics, which is animating things. So this was quite a challenging aspect of the game. So animation is a crucial part of a game. It's one of the things that gives that extra layer of, like, immersion and richness where, like, someone can really get lost in a game. But I didn't really know how to achieve this using the kind of Elm style architecture that we had. And one thing I found particularly tricky was breaking down the problem in a declarative way. So I'm going to try and illustrate this with an example. So this is the loading screen without any animation applied. And imagine that we've got like a Boolean flag that's being flipped from true to false, which is representing whether it's visible. So you see, like when the user clicks, that Boolean flag is flipped, and the transition happens, or the transition happens immediately. But the thing with animations is that like animations live in between state transitions. So the trick was how do I model this? So with that in mind, I had a kind of an ideal animation system that I'd like. So I'd really like declarative units of animation, like a value, like everything in Elm has to be a value, ultimately. They have to be composable, so I want to be able to string these values together to create one single animation. It's got to be performant. Like, people will not tolerate games that chug along at 14 frames a second. And I also, from the React version, I'd kind of come up with this idea of like a timeline that I found really nice, a kind of nice mental model to work with. So it would kind of be like, something starts here, then it moves over here, and then it's going to explode into like a ball of confetti or something. And then what if I could have like state changes along those events? That could be kind of cool as well. So I started trying out a couple of different things given that those thoughts. So I tried Elm-style animation. I think Matthew's in the audience here. Hey. It is a great library, but unfortunately, it didn't really work with mine. Like, I started trying to use it in the board, and it just chugged along. So, as much as I loved it, I had to abandon it eventually. I tried GreenSock and Anime. They're both JavaScript animation libraries. That was a horrible experience. Let's not talk about that. That was bad. So eventually, I just arrived at like 100% CSS. So I'm thinking, why CSS? Like that thing that we use layout for that's really tricky. So why CSS? Why did I arrive at CSS in the end? Well, interestingly, like CSS styles themselves are declarative and composable. You can string styles, you can combine styles together to give you a composed effect. They can be mapped really easily to state changes because of their declarative nature. So like the toggle on and off for the true-false state, you can use different styles depending on whether it's true or false. They're really performant. If you stick to certain CSS properties, you can get like a 60 frames a second, really smooth animation. That was really surprising. And it's so simple. It's just an inbuilt thing native to the browser. So this is an example of some of the styles that we use for the loading screen. So the one on the top is a transition style. So that reads as like over 0.5 seconds when the opacity is changed, fades smoothly between those two values. And then if the screen's visible, have the opacity 1, if it's hidden, 0. So this is what it looks like with that, with those transitions applied. And I was really surprised, like how just 3 lines of code gives you this really like quite high fidelity looking effect. So then, if you want to animate multiple steps, you can use CSS animations, keyframes. So this one is one that I use in the live counter, so like the little heartbeat animation. This was really nice. Like, you can use this handy little property at the end called infinite, so it can loop around. It's like, my heart beats for you animation. It's great. Yeah. So there's not much code there, and you already get this really like quite human-looking effect, which I was really surprised with. So let's take it up a notch. I'm going to do some flowers now, which is really cool. So these are all. This is using a similar kind of animation, and what you can do here is you can apply this animation delay property. So this was where SVG, CSS, and Elm all came together, and I was just like, this is everything. I was so excited at this effect. I was like, it's quite for my mind, it's quite impressive, but there's really not much code. So I was sold. Like, it's so much fun to work with, and how little code there is, and like how easy it was to change stuff up. It gave a really like powerful flexibility in like trying out different stuff to get like the look and feel of the animation. But what about timeline? CSS is not all sunshine and flowers. So it's great for simple transitions, but it's quite difficult to map these different animation steps to state. And what about state changes that are not just on response to like a user interaction, like a click or a pointer move? So one example I've got here is like a user interacting with the board. So this is a type that represents like some of the different states that a tile can be in. So at the beginning it starts as static, and then when the user's dragging, it can be dragging. But these last 3 steps, when the user lets go of the mouse or their finger, the tiles will leave up to the top, some of them will fall, and then new ones will enter. So that was quite tricky to do with CSS alone. So how did I solve that? Well, I ended up making this sequence API. So basically, this is just a command that you can fire which will send a bunch of messages to update after a period of time. So you can read this a little bit like, after 200 milliseconds, update will receive set leaving tiles. Then after 100 milliseconds, reset move, so on, so on. And basically, this is just a glorified sequence of set timeouts. And this does have some trade-offs. Like, it's not you're not guaranteed that all the durations of the animations will stay in sync with what you specify in the command. I mean, this could be guaranteed. Like, it could change it, but I just haven't really felt the pain of it yet. And it does end up with lots more messages in your update function. But the benefits were that I found it really expressive. It was really nice just to read like a list of what's going to happen in an animation. And you get this really fine-grained state control. So I've had like there's some points in an animation where I want to disable parts of the UI or like reset certain bits. And it just lets it, that kind of API has given me the power to be able to kind of change state in a very controlled fashion. And one of the nice effects that I wasn't expecting was that it's really, really useful for debugging. So I'm going to show you an example of that here. So this bit, this is a scene when you, so like when you finish like a final level in a world, you're kind of like, you've collected all the resources and then you save this flower for the world. So you can see like on the right that these messages are coming through to update. Just wait for it to fade out. But the nice thing about this is that because we have all of these messages, we can just replay bits of the animation. So this was actually really, really handy for debugging stuff, like trying out different things, like getting the look and the feel and the timing of the animation. So I wasn't really expecting that, but that's actually been one of the most powerful side effects of that API. So that was an interesting experience. Right. So I want to close with like a couple of thoughts. I've had so much fun making this project. It's just been a really fun experience. I mean, testament that I'm still working on it now, even like 2-3 years later. And I believe that Elm has played a huge role in still making it fun and keeping it fun to work on. It's just been the experience of like refactoring, changing stuff up has just been so stress-free. And I think the emphasis on keeping stuff simple, which I think Elm has encouraged me to do as well, just keeping everything from getting too complicated has really kept it fun and kept it sane as well. And if you're interested in making games in Elm, I would seriously encourage you to give it a try. It's a lot of fun, and it's amazing what you can actually do with it. Like, kind of like bringing back the Flash days of having little games in the browser. It's like, we can make it happen. So I've got a couple of like next things that I'd like to do with the game. It's like I want to add some more mechanics and more levels. There's only 15 levels at the moment, so we need more levels, more flowers, more seeds. I want to add some like sound effects and music. I'm actually going to start working with a colleague of mine on composing some music for this, which should be really exciting. And then maybe like try and deploy this to iOS and Android using like a Cordova wrapper. That could be kind of fun. So I want to say a couple of thank yous at the end. I want to thank Richard, because 2 years ago at an Elm meetup in London, you actually convinced me to give Elm a try for making this game, so thank you. I want to thank Derek Romer, who made the SVG to Elm tour, which has saved me so much time. It's unreal. Like, that has been amazing. I obviously want to thank Evan for making Elm in the first place, and the wonderful Elm community for making it such an exciting and fun experience and tool to work with. And of course, I want to thank all of you here for listening.